Hey guys, this is Mr. Kruger here, walking you through the review for the Chapter 6 test in Algebra 2C. We're going to start off with the first set of problems, numbers 1 through 3. It states, find the domain of the following in interval notation. So what we need to do is we need to find the excluded values. And the way we do that is we set our denominator equal to 0. And the reason we do that is because if the denominator is equal to 0, that means that this function will be undefined. Okay, so if we set the denominator equal to 0, we solve for x by adding 3 to both sides, dividing by 2, and we're left with 3 over 2. And now what we're going to do is that tells us what is the excluded value. So I'm going to write an interval notation starting from my lowest bound and working up from there. So I'm going to go from negative infinity up to 3 over 2 with parentheses because it is not included. Correct the union. Start right where I left off at 3 over 2. And write it up to positive infinity parentheses. Okay, number 2, same idea. We need to find the excluded values. So I'm going to take my denominator, x squared minus 100, set it equal to 0. And I still need to solve for x. So I'm going to do this by factoring. So I'm going to rewrite it as a trinomial. X squared plus 0x minus 100 equals 0. So I need to find two numbers that multiply to 100, negative 100, and add to 0. So that's going to be x minus 10 times x plus 10, set it equal to 0. Okay, now I'm going to set both of those mini equations equal to 0 and solve for x. For x is 10 and x is negative 10. Okay, so now what I'm going to do is I'm going to write my interval, but this time we have two excluded values. So I'm going to start at negative infinity, go up to my lowest point, which is negative 10, union negative 10 to 10, union 10 to positive infinity. Okay, and notice that negative 10 and negative 10 are next to each other in the interval, and 10 and 10 are next to each other. Okay, zoom in if you need to see that right there. Okay. So now let's work on number 3. Same idea. I'm going to set the denominator, 3x squared plus 3x minus 18 equal to 0. But now I need to factor. So I'm going to look for a GCF first to see if I can make my life a little easier. If I factor out of 3, I'm going to be left with x squared plus x minus 6 equals 0. And now we can factor this trinomial. We need two numbers that multiply to negative 6 and add to 1. That's going to give us 3 and negative 2. So if I factor that, I get x plus 3 times the quantity x minus 2 equals 0. I need to set both those equations equal to 0. So then I have this. And now if I solve, I get x equals negative 3 and x equals positive 2. Now just like we did in number 2, we need to write an interval notation. So I'm going to go from negative infinity to my lower number, which is negative 3. Interval. Start at negative 3 again and go up to 2. Union 2 all the way to positive infinity. Okay, so take a second and look at all three of those answers. What you'll notice is that the excluded values are right next to the union. Okay, and this is always going to happen. You'll see negative 3 to negative 3. Right where you stop, you start up again. 2 and 2. And you're always going to have negative infinity on the lowest number and positive infinity on the highest number. Now let's start with the second section. What I'd like you to do is pause this right now and take about a few minutes to try these problems out. All we're doing is evaluating. So we need to look for the function f of x, and then we need to plug in or substitute negative 2 wherever you see an x. Okay, so pause the video right now and try these problems yourself. Okay, let's jump right in. So for number 4, function f of x, that's going to be this first function right here. So now I know I'm dealing with that function f of x. So now wherever I see an x, I'm going to plug a negative 2 in. So if I do f of negative 2, I need to make sure that I'm using parentheses, squaring it, minus 2, negative 2 minus 1. In the numerator, negative 2 squared is 4. 4 minus 2 is 2. Negative 2 minus 1 is negative 3. So if I substitute negative 2 wherever I see an x into the function f of x, I do get a negative 2/3. Okay. Number 5. I'm looking at the function g of x. Wherever I see an x, I need to substitute a negative 1. So g of negative 1 equals 2 times negative 1 plus 1 over negative 1. That gives me negative 2 plus 1, which is negative 1, over negative 1, which equals positive 1. Make sure you can see that. Let me make it a little darker so I know it's right on that one spot right there. And last but not least, f of 0. Okay, so I'm going to plug a 0 in wherever I see x. So 0 squared minus 2 over 0 minus 1. That gives me a negative 2 in the numerator and a negative 1 in the denominator, which simplifies to positive 2. Okay, so take a look at all these. We should be able to evaluate, but now we're evaluating given a rational expression. Now we're going to jump into numbers 7 through 12. Now, numbers 7 through 12, we need to simplify, and we need to multiply and divide. Okay. Now what I'd like you to do is take out a separate sheet of paper just so we make sure we have enough space to do these problems. And I'm also going to use a separate sheet of paper on a few specific side work pieces where I need to factor when the trinomial does not have a coefficient of 1. So if I start looking at number 7, okay. Now the way we did it in our class is I rewrote it as a trinomial with all 3 terms in front of us. So my numerator is going to look like x squared plus 0x minus 16 over x cubed minus 2x squared minus 8x. Okay, the reason why I did that is so my students can see that we need 2 numbers that multiply to negative 16 and add to 0. So the way we factor that is we factor it into x plus 4 times x minus 4. Now if you look at the denominator, we're not given a quadratic. We're actually given a cubic, meaning x to the 3rd. So first we need to find the GCF. So if you notice that they all share an x. So if I factor out an x, I'm left with x squared minus 2x minus 8. And we still need to continue to factor that. And the way we do that is we need to look for 2 numbers that multiply to negative 8 and add to negative 2. So you should get negative 4 and positive 2. So I'm going to continue to factor that. I'm going to leave my numerator exactly the same, x plus 4 times the quantity x minus 4. I'm going to leave that x out front, but now I have x minus 4 times x plus 2. And now we have 3 factors in the denominator. Okay, I'm going to keep parentheses around all 3 of them just so I know they're all factors. So now what I'm going to do is I'm going to look for commonalities in the numerator and denominator. Now I see that there's an x minus 4, so I can cross those out. And what I'm left with is an x plus 4 in the numerator over an x times the quantity x plus 2. And I can leave my answer just like that. Okay, let's try number 8. Number 8 is just like number 7. We need to simplify first. And the way we're going to do that is we're going to factor. So take a minute right now to pause the video and try this yourself. Okay, so let's jump right in. If you notice the numerator and denominator, they are both trinomials with a coefficient of 1. So in the first one, we need to find 2 numbers that multiply to 12 and add to negative 7. Okay, those 2 numbers are x minus 4 times the quantity x minus 3. In the denominator, we need to find 2 numbers that multiply to 20 and add to negative 9. In this case, it's x minus 5 times the quantity x minus 4. And now just like the last problem right here, I need to find commonalities in the numerator and denominator. And what you'll see is that x minus 4 is in both the numerator and denominator. So I can reduce those because any number divided by itself gives me 1. So now what I'm left with is x minus 3 over x minus 5. And that's my final answer. Number 9. These are still considered rational expressions, but now we have to think back to our exponent days. So what I'm going to do is I'm going to try to find any commonalities in the numerator that I see in the denominator. Okay? So I'm going to multiply the whole numerators together, so I get 12 x squared y a b cubed over 24a b x cubed y to the fifth. And now I need to remember my exponent rules. How can I simplify the coefficients 12 over 24? Well, in fact, they simplify to 1/2. So I'm going to write a 1 over 2. Next, I'm going to look to the x's. X squared over x cubed. Okay, remember, if there's division, we're going to subtract the exponents, which gives us an x to the negative 1. Okay, so I'm going to put an x to the negative 1. Now let's go to y. Y over y to the fifth. Again, subtraction, which gives us y to the negative fourth. Now let's look at a. A to the first divided by a to the first. That simplifies to just 1, so we don't need to put that. And b to the third divided by b gives me just b. But we don't need negative exponents. And the way we bring a negative exponent to become positive is we flip it and put it in the denominator. So my final answer, I'm going to keep the 1 on the numerator and the b, but now I'm going to have in the denominator 2x, which is just x to the first, and y to the fourth. And that's my final answer. Now let's look at number 10. Number 10 is just like 7 and 8. Okay, but we're going to have one more step. Now we need to multiply two expressions together. But first, let's factor. In the top numerator, top left numerator, we have to factor out a GCF. So I'm going to factor out a 2, and I'm left with x minus 3. In the left denominator, it's all GCF again. I need to factor out a 3x, and I'm left with 2x minus 5. Now I'm going to start with the second expression. GCF again. I'm going to factor out a 4x, and I'm left with x minus 3. In the denominator, I can factor out a 9x squared, and I'm left with 2x minus 5. Okay? And now what we need to do is we need to look for any commonalities that we can find. Okay, if you notice, the only commonality I can see is this x right here and this x right here. So I'm going to cross those out because x divided by x is just 1. And now my final answer, if you want to leave it like this, I'm totally okay with that. 2 times x minus 3 times 4 times x minus 3 over 3 times 2x minus 5 times 9x squared times 2x minus 5. But for me, I'm going to multiply the coefficients together. So I'm left with 8 in the numerator, which is 4 times 2, times x minus 3 quantity squared, because there's 2 of them, over 3 times 9 gives me 27x squared, and I have 2x minus 5 quantity squared in the denominator. Okay? Now number 11. Number 11, I'm going to use a little bit of side work. Okay? So now let's look at number 11. Well, you'll notice that we have division. So the first thing I'm going to do is I'm going to flip my second term. So I have 2x squared minus x minus 3. I'm going to keep the first one exactly the same. But I'm going to flip the second term and take that reciprocal. So I have 5x squared minus 1 in the numerator, and 3x squared minus x minus 4 in the denominator. Okay, now what I'm going to do is what you'll notice about all 4 of these expressions, these polynomials, is that we need to group. Okay, so what I want you to do is I'm going to put up the problem showing by grouping, starting with 2x squared minus x minus 3. So that's how you group. Okay, so pause it right here. Next, that denominator, 2x squared minus 5x plus 3. This is how you group. Pause it. Next, 3x squared minus x minus 4. This is how you group. And lastly, 4x squared minus 1. This is how you group. Okay, so now I'm going to put those expressions in there. So I have x plus 1 in the numerator and 2x minus 3 over x minus 1 and 2x minus 3 times 2x plus 1 times 2x minus 1 over x plus 1, 3x minus 4. Now I'm going to find commonalities. I see a 2x minus 3, 2x minus 3, I see an x plus 1 and x plus 1. Now what I have left is 2x plus 1 times 2x minus 1 over x minus 1 times 3x minus 4. Okay. Now last but not least is number 12. Now there's three different expressions being multiplied by each other. We don't have to switch any terms because they're not division, but we do need to factor all of them. So the first one, x squared minus 16. I need two numbers that multiply to negative 16 and add to 0. So I get x plus 4 times the quantity x minus 4. In that denominator, I'm going to take out a GCF. So I take out a 6, and I'm left with x minus 1. I'm going to start the next expression. I need two numbers that multiply to 6 and add to 5. X plus 3 times the quantity x plus 2. In that denominator, I need two numbers that multiply to positive 16 and add to negative 8. That gives me x minus 4 times the quantity x minus 4. And the last one, I'm going to look at the GCF. So I'm going to take out a 2. And I get x minus 4. And now I need to factor this last trinomial. I need two numbers that multiply to 8 and add to 6. So I get x plus 4 times x plus 2. Okay, and now what I need to do is I need to find commonalities. Okay, I see an x plus 4 right here and right here. See an x minus 4 right there and right there. X plus 2, and another x minus 4. And in fact, I can simplify this 2 over 6 to 1 over 3. So I have 1 times x plus 3 left over 3 times x minus 1. And I'm completely okay with leaving it just like that. So now what you can do with this video is you can rewind, pause, stop, and start all over again to look at all of questions number 1 through 12. Okay?